We're back, and this time we're announcing our new Understanding Stellar Energy report, which is a return to the energy space for the RethinkX team. This is a super exciting one because this is an opportunity for us to show how solar, wind, and batteries, these disruptive technologies that we first wrote about 6 years ago and some of our early energy work, and that one of our co-founders, Tony Seba, has been writing about for more than a decade, well over a decade now. We get to talk about how those are connected to Tony and James Arbib, Tony and Jamie, our founders' new book, Stellar, which is about a world beyond scarcity, a world of superabundance, and in particular one that's enabled by the clean energy superabundance that we can create with energy systems based on solar, wind, and battery. I'm super excited about this. This piece of research has been in the works from our team for a long time, a couple of years. And so it's really exciting to begin to be able to announce this and start really dig into the ideas that we cover here, which extend the work that we have done in the past in some really interesting ways. So yeah, let's talk about that and give people a sense of what this report is about.
Sure. So a couple of years ago, we had originally published our Rethinking Energy report, Rethinking Energy 2020 to 2030. In that, we proposed the idea of solar, wind, and batteries as a way to power humanity's future, and showed that it was possible, it was practical, it was a lot more affordable than most people would think, and it had some surprising effects, some surprising unintended consequences. One of which was this idea that if you're powering your electrical system off of solar panels and wind turbines and then using those to charge batteries, you build an electrical system that's going to get you through the worst periods of the year when you don't have a lot of sunshine, you don't have a lot of wind, and you need to use your batteries. So you're going to be using them every night, basically, but also at certain times of the year when you just don't have a lot of power. But what that means is that there are going to be times when your batteries are full. So your batteries have filled up and you're generating solar power, maybe you're generating wind as well, and you're generating more than you're currently consuming. So you have a superabundance of power, what we call superpower. And what do you do with that power? Well, you're not going to store it in the batteries. Your batteries are full. And you don't need more batteries because you have enough batteries to get you through the worst periods of the year. You've sized the system for those events. So you just have an excess of power that you can't store that has literally zero marginal cost. If you don't use it, you lose it. So, you might look for ways to use that power. And so we published that report, but we realized there's limits that we had put on and constraints on that system. We were quite restrictive in our assumptions. So let's relax some of those assumptions. One of which is this idea that you only get this excess of power when your batteries are full, because that's not really strictly true. If you've got forecasting of tomorrow's weather and you know it's going to be sunny, not rainy, or it might be windy, and weather forecasting is decent these days, and you know what it's going to be like tomorrow, maybe you know you're going to wake up with 50, 60% battery or more, or even 30, 40%, then why not use that power that's in the batteries? You can use this excess of power anytime you want, as long as your power production capacity of solar and wind is greater than your average usage, then you can use the batteries at any time. You have superpower available when you want it, not just when the batteries are full or at noon on the sunniest day. So I think that was the spark that kicked off this next round of investigations, was what if we relax that assumption that superpower is only available when your batteries are completely full? What if you get a little better in forecasting, not only production, but also your demand, right? A little better at planning. Whole new windows of possibility open up when you start relaxing some of these assumptions.
What we realized is that with a full and comprehensive understanding and view of what SWB Superpower actually is, and that with this surplus beyond nominal energy demand that we see, you are really talking about an energy system that is leveraging this property that superpower is produced to deliver clean energy superabundance for most of the hours of the year. And so we have a formal definition of superabundance that's crucial to onboard here. And that is that things are superabundant when the marginal cost is near zero and when the supply that's available hugely exceeds, it outstrips your nominally demanding from that resource. at any given average time. Something is superabundant when it's extremely inexpensive and readily available. Fairly commonsensical definition, but very counterintuitive to the way that our energy systems work today. Today, every kilowatt hour of electricity that you utilize from a coal power plant or a gas-fired power plant or a nuclear power plant, every kilowatt hour is expensive. Every kilowatt hour is a significant cost. It's non-negligible. It's not near zero. It's very definitely there's a cost to that energy. And the more that you use, the more it scales because of the fuel that you have to put in, because of the expense of operating the facility, and so on. The logic there, when you have a system that's based on the flows of those fuels in, as opposed to just having built the stock of the power plant itself, which is what you've got with solar panels are just a stock, batteries are just a stock. When you've got this different logic of the system that we have today, you're incentivized to be efficient in your usage by using as little energy as possible. Save as much money as possible by using as little energy as possible. And that is not a formula that gets you to superabundance. That's a formula that locks you into scarcity. And unfortunately, energy scarcity is associated with everything bad. And energy abundance, and superabundance especially, is associated with everything good that you could care to measure about human life. So pretty much every metric of concern that you look at with human development has a very strong positive correlation with per capita energy utilization. So you want more energy per person used in practice in order to achieve widespread social prosperity. And so the entire incentive structure of the existing energy system is sort of anti-human. And of course, that came just racing into view when we, as you said, relaxed the original assumptions around a solar, wind, and battery-based energy system. And we saw, this is the key. This is the key to a stellar energy system. And the building the core that unlocks a stellar world at large, which is you architect, you design your energy system around this property of superpower. That is the thing the principle that you build it for. That's what you're trying to maximize. That's the prize. That's the key that unlocks the door to clean energy superabundance. It isn't just it absolutely is not a problem, which is how it's framed in the existing context, the existing incumbent energy system under the current status quo. Surplus electricity that's very, very cheap, in other words, it has a near zero marginal cost from solar power plants and wind turbines. That's a problem for the existing system. That floods the wholesale markets with electricity at near zero cost that puts downward pressure on the clearing prices in those markets, which is terrible if you're a coal power plant operator or nuclear power plant operator. So the way to think about this from the conventional perspective is that, superpower, that surplus is terrible. That ought to be curtailed. We need to do as little of that as possible. And of course, that's upside down, that's backwards, and it runs contrary to real human interests. And once we've started putting those pieces together, it became clear to us, okay, there is much more to this energy story than we originally realized in our 2020 report. And we needed to come back and revisit this and share that understanding of what a stellar energy system can and will look like with our audience and with the global public. And not just what will it look like in a handful of areas that are particularly sunny, but what will it look like everywhere, because solar, wind, and batteries can be the basis of a stellar energy system everywhere on Earth, everywhere where people actually live. So maybe not like literally at the poles, but even at very high latitudes, counterintuitively, high latitude places, solar, wind, and batteries are going to work and give you a stellar energy system if you architect it optimally around this principle of superpower. And Brad, you can talk directly to this, and we've laughed about this before, but you happen to live in a very high latitude location, right?
I live in Norway, in the southern part, where even in the summertime, it never really gets dark enough to really call it night. So I say that, in Norway, day and night are more of a social construct than an actual astronomical phenomenon, because the sun sets in the northwest and rises in the northeast, because where I live, it only dips below the horizon a little bit. So you can watch the sun set and the sun rise at the same time. Just because, it's setting one place and you can see the first rays of light coming from the other direction. Norway gets as much sunlight as anywhere else on Earth on average. It's 12 hours for everywhere, basically. There's more variability the further north or south you go, but you get the same average. So if you're building solar panels, and they are here, I mean, there are houses with solar panels on the roof. The panels have just gotten cheap enough that people just build more panels. And if you want more power, you build more panels. Lithium ion batteries now, both of these things, solar panels and lithium ion batteries, are 10% of the price that they were 10 years ago. I mean, they've literally come down 90% in the past 10 or 15 years. So you put in a battery storage system in your house, you have solar panels. Electric cars, of course, are very popular. You have solar panels on your roof, you're charging batteries in your house, you're charging your batteries in your car. And if the power goes out, you can run electrical system off of the batteries in the house, or for some cars, you can take power from the cars. But it means that you don't ever really worry about the power being out, because you always have this local system. There's no worry about a grid collapsing. Norway gets a lot of its power from hydropower, but if anything ever goes wrong with that, you can run off of your home battery system if you have that. If solar panels continue to get cheaper into the future, battery storage is getting cheaper, electric vehicles are getting cheaper, then all of this just becomes more abundant. You get to the point where you are generating enough power throughout the course of a day, a week, a year on average, that you can be using this excess zero marginal cost power anytime you want. And like you said, the fundamental difference here is there's no fuel. When you have fuel to feed into the system, whether it's coal or wood or natural gas or anything else, you want to minimize your usage of power, because that minimizes your usage of fuel.
Right.
They're based on this stockpile of solar panels that you have in your local area, the stockpile of batteries that you've built, the stockpile of wind turbines. And if you have, once you essentially paid up front for your power by putting these relatively cheap solar panels on your roof, or now relatively cheap batteries or wind turbines, if you've built that stock, they're generating power for free. So now it totally flips the system. You go from worrying about how do we minimize our power usage to how do we maximize the benefit that we get from this excess of power that we have. And it's no longer, the way that we have been thinking literally for hundreds of thousands of years or more about power, about energy and heating and everything else, which is, reduce it as much as you can. It now becomes get the most benefit that you can. And we know that human well-being is very strongly correlated with power consumption. So not just electric power, but all sorts of energy consumption. So the ability to travel around, the ability to light your house, to heat it or cool it to whatever temperature you like, to maintain whatever level of humidity you want, to cook your food when you want, to bathe in warm water, all of these things are correlated with well-being. And not just correlated, but there seems to be a very strong causal connection between using energy and living a healthy, happy life. An SWB system that is sized appropriately, that it's generating excess power, superpower throughout the course of the year, means that it completely inverts basically everything about the way that we think about our energy system, and therefore a lot of the rest of life too.
Yeah, that's absolutely right. And I mean, the electricity that's generated by a stellar energy system is clean, it's near zero marginal cost, which means it has near zero financial cost, economic cost, environmental cost, social cost, right? Health cost, none of these massive costs that are associated with, on a linear basis, every additional increment of coal you shovel into the power plant, for example, all of that disappears, and it inverts into a system where the electricity is the benefit that is simply there. It's just hanging there, right? The solar panels are going to produce the electricity from the photons from the sun that fall on them, whether you use that electricity or not. It then becomes incumbent upon us to make the best use of that, as you said, as we can. And one of the things that we found over the course of investigating SWB Superpower specifically is that, okay, there's going to be this enormous superabundance of clean electricity. That's the path, number one, for electrifying everything. So this is an open question, like, oh my gosh, what about all the industrial heat that we have to use? What about all of the processes that, transportation being a major one, that don't just utilize electricity today? We burn fuels to obtain the heat from them or otherwise obtain the energy from them. Well, now we see a path via clean energy superabundance from SWB via superpower to electrifying everything. And we've known that's necessary as a next step, but it wasn't clear how to do that in any affordable, financially affordable, environmentally affordable, socially affordable path. How on earth would we do that? Well, now it's clear. It's clear. You do that with SWB-based stellar energy systems that are cranking out this enormous amount of what we are calling superpower. Okay, if you have clean energy superabundance, if you have this electricity that's near zero marginal cost, how can you take advantage of that? One fun insight was that on the one hand, you can look for what's that killer app? You got to look around. What is going to be the killer app for this ultra low cost or near zero cost electricity? If electricity were effectively free, what business model could you set up around that? What would be the killer app for that? Well, that's one way to think about it, but we realized that's one-dimensional thinking. And probably the real successes are going to be killer combos of utilization. So it isn't just going to be one business model. It isn't just going to be one industrial process or one application that's going to meet with success here and turn out to be how this gets utilized, how we really knock it out of the park with this. It's going to be 2, 3, 4 types of energy use all together in combination with one another that are where the real spark, where the real value is going to ignite there. And so a fun example that we've thought of, there will be many combinations, surely some that are almost unimaginable from our perspective today that will be discovered for sure. But one that's fun to think about is AI, right? You can't look at the news these days and not hear about all the energy that AI is going to require, right? So that's one obvious application. And fair enough, it would be a killer app for clean energy superabundance from SWB Superpower. But if you're running all of that AI, if you're powering data centers and supercomputing clusters with this clean electricity, what do you get out of the end of that as a waste product? You get waste heat. You get heat that you can't use, heat that's a problem for all of the server racks, for the AI facility itself. When you're done using the electricity, the heat is a problem. But guess what? That heat can be an input, a really valuable industrial heat input into another process. And one that is very close to the top of our minds at RethinkX is precision fermentation and cellular agriculture, these new food technologies, which require a huge amount of energy to maintain climate control in their facilities. That's what they need energy for. They need energy to make sure that the bioreactors are at a nice, comfortable, constant, and really quite warm temperature in order to be thriving. For lots of parts of the world that are going to be doing enormous amounts of precision fermentation as a result of the food disruption, they're going to need low-grade heat. Not heat that's thousands of degrees like you would need to smelt and recycle metal, but heat that's a lower temperature. So the waste heat that's coming out of your AI data center or supercomputer could easily be the input into a paired operation with precision fermentation. So that combo of industrial use of superpowers is an example of the kind of winning formulas we expect to see. Totally alien from the perspective of the incumbent energy system. So that kind of thing is going to be really fun, not just for us to continue thinking about, but for industries of all kinds across the globe in all geographic regions to start thinking about, because these enormous new possibilities are going to be opening up. Things that were literally unthinkable in the past, with expensive flows of fossil fuels being the basis of our energy system for 150 years. So this really is a transformative moment. Let's talk about the status quo.
Yes, absolutely.
Okay, so speaking of the status quo, when we were constructing our scenarios to do an analysis here, we categorically rejected the status quo this time around. Rather than that being the focus of the analysis, rather than accepting the world as it is, the world of energy as it is, we decided to rethink what energy means for human beings in a stellar world. And that kind of rethinking meant throwing the status quo out the window completely. Because the truth is, unless you're lucky enough to live in an energy abundant society like the United States or the Gulf countries in the Middle East, you're not getting anywhere near enough energy utilization, energy availability per capita, not anywhere near enough under the status quo. As we were saying earlier, energy use per capita is enormously strongly correlated with human well-being across every metric that you can measure, every single one, virtually without any exceptions. And there are no countries, there are no societies, now or historically, where prosperity and human well-being have been high across the board, but energy consumption has been low per person, and vice versa. There's never been a society where energy consumption per person is very high, but human development by all these other metrics is low. We don't see that either. It's an enormously strong association. So what that means is the status quo today is not good enough for the majority of the world's population. Most people need to start using much, much more energy. The baseline case in our analysis here is therefore the standard of living that you currently enjoy on an energy basis in Western Europe. That's the low end for every human being everywhere on Earth. That's the low end of a stellar energy system. And the high end is much, much higher than that. And so this is what we're expecting, is energy use in the future is going to be much higher per capita in most places. And for humanity as a whole, it's going to be enormously greater than today. The only way we could conceivably achieve that at an acceptable financial and environmental and human and social and health cost is with solar, wind, and batteries. We couldn't possibly achieve that with any of the older incumbent energy technologies. Our analysis is not a forecast of what the incumbent status quo system would look like if you just dropped solar and wind and batteries in to replace a few of the coal power plants and a few of the gas turbines and so forth. No, it's not that at all. We disregard the status quo. We disregard the current configuration and the current limits of the system completely. And instead, we ask the much more important, the much more relevant question of what kind of energy system should humanity have? And the answer is that it's a stellar energy system where there's enormously more energy, clean energy, available for everyone, everywhere. And there's a sense in which the older energy system is failing the overwhelming majority of the world's population. And that's not acceptable. That is not good enough. We can do so much better. And now we know how. Now we see the way to get to that stellar world. So that's enormous cause for excitement and optimism here too, I think. Seeing the path that's available for us.
Yes, absolutely. So again, I think the key difference here is flows versus stocks, of consuming something versus just having a stockpile of units that are producing the power or storing the power. And the analogy that you have used in this conversation, the one that Tony and Jamie have used in their book Stellar, is like a star. So why do stars shine? Because they have a certain amount of mass. You get enough mass together, they start shining. And I'm not an astrophysicist. I don't know what that limit is, but I know that Jupiter doesn't shine in its own light, and it has a lot of mass. And I know the sun does, and it has more. So somewhere between Jupiter and our sun in mass is where an ignition point occurs, and you start glowing under your own light from fusion power. And we don't have fusion here on Earth, but we do get the result of that through sunlight. Sunlight ultimately drives all of the movement of the wind. So wind is effectively a form of solar power too. Basically, all of our power comes from the sun. Even when you think about it, coal and wood are fossil.
They're just old sunlight.
Yeah.
Yep.
So ultimately, it all comes from the sun. And now we can actually economically gather sunlight, store it economically, and use it whenever we like. And that's a completely different system. And it's one that's freed from the need to burn a fuel. It's one where we are freed from our previous thinking about how power should work, where some parts of the world have a lot and others have less. Some parts of the world have a lot of oil and gas just by accidents of geography, and we need to ship that to someplace else to use it. And we're going to ship it and we're going to burn it once, and it will turn into pollution, and we get one usage out of it, as opposed to building a solar panel and getting to use it every single day continuously without the side effects and without having to continually move fuel around. So it's a system freed from our previous thinking about how power systems should work, and it's one that becomes a system of superabundance and therefore requires rethinking how our energy system works.
Yeah, absolutely fantastic. Well, we're going to wrap it up here. There's so much more to talk about. We'll be doing deeper dives into lots of the specific ideas, lots of the specific topics that this new report covers. So we're going to come back to those and revisit those. But this is just a quick overview. It's fantastic. It's such an exciting and enormously uplifting vision once you start seeing how these pieces come together Can't wait to share it with the world. Can't wait to hear everybody's reactions. And we can't wait to start working with people to build the stellar energy systems that are going to power a stellar world going forward. So yeah, stay tuned for everything. We'll be back for the next one where we do deeper dives on many of the topics that we talked here and a few that we didn't get a chance to cover. And then stellar energy is only the beginning. It's only one of the pillars of a stellar world. And the other ones are as fascinating as well. So we've got a lot more stuff to cover and tons more videos to come. So we'll see you next time.